everyone. Can you especially hear me well there? Okay, amazing, cool. So hello everyone. My name is Bilge. Maybe I can directly go into this way, like for presentation, just to like refresh our knowledge around AI. I don't know like much about you and your experience, so we'll just like we'll have a refresher in this presentation. I'm a senior developer relations engineer at Deepset. I did my bachelor's in computer science and my master's in artificial intelligence. And for the last 3 years, I've been learning and teaching how to build AI and how to build with Haystack. I am active on Twitter and on LinkedIn. So if you have questions, if you want to connect, you can follow me there, send a connection request. I will be reviewing them after the workshop. And just one slide about Deepset, the company I'm working for. Deepset was founded in 2018, and for the last 7 years, we are providing custom AI solutions to big enterprises. And like big enterprises, I mean, there's Airbus, Siemens, and now there are also many German public sector organizations such as BMFTR. If for German-speaking people, I think it's like Federal Ministry of Technology Space. I missed something, but that one. And there's European Commission, and there's Site Online, if you know that one. And among our customers, so these are like some of them are using Haystack open source, some of them using our enterprise solutions. And yeah, as I said, Haystack, this is gonna be the product that we're gonna focus on is an open source AI orchestration framework. I will go into the depths of it later. We also have enterprise solutions for our bigger customers. Now I wanna learn a bit about you. Just wanna understand, like, have you built an agent before? Can I see hands if you have worked with agents before? Okay, so it's like the 20% of the room. Nice. Okay, then by the end of this workshop, I think everybody will be able to like raise their hands because there will be a very useful agent that is useful for me after this. I was talking about agents, but now it's retrieval augmented generation because we're gonna be touching like to retrieval augmented generation, and I wanted to make sure that we know what that is and how we can implement something like that. And are you familiar with the term retrieval augmented generation? I see not mostly. Okay, then quick refresh. Let's go. So it's basically giving a very sophisticated prompt to our brain, to our LLM to get an answer. That's the whole idea. So just like we don't just ask a question or like send a query to our LLM, but we put some instructions, we put the context, then we put our query. So that's basically the whole idea, retrieval augmented generation. So in this approach, we use LLM's generative capabilities, so not their knowledge. You know, like LLMs are trained with huge data sets, but there is always a certain time, like there's always a cutoff time, so they don't know what's happening in the world after that time. So with this approach, we just give them the context, so they always know. They always have information around the query that we are asking. How we augment the prompt is through a retrieval step. I will be showing you the image of that. And with this approach, first, we don't need to rely on LLM's own knowledge because we're going to provide the knowledge. Sometimes LLMs, and usually LLMs, don't have information around our internal data. So if you imagine you are working at a big organization, you have like lots of files, maybe these are customer files, maybe this is like an internal document. But when you think about the large language models out there, they don't have access to those information. So if you want to use these models running on your data, you need retrieval augmented generation. And the use cases like customer support, FAQ, enterprise knowledge bases, search engines, etc. So I mentioned a bit about the benefits of RAG, but if we need to repeat them again, with this approach, we can build an application that can run on our private knowledge. Our LLM or our system will always have up-to-date information, so there won't be any out-of-date information. We are reducing hallucinations, so we are making sure that LLM has the relevant context, so the answer that it produces always grounded on the context. It's cost effective, so we are not training a new model like every time we have real data, like we were doing back in the machine learning days. We just put the relevant information into the prompt, and it gives us transparency because we know the context that LM generated the answer from, so we can always go back and check the groundedness of the system. And when we look at that, it's basically consists of two steps: retrieval and generation. The retrieval part is basically getting information from our database, and there are different approaches here. You might be building a similar semantic search application or similar semantic similarity retrieval. You might be doing BM25. You might be doing a hybrid retrieval, basically combining keyword search and semantic search together to find relevant information to your inquiry. Then you put that information to your prompt with the user query, and you pass that sophisticated prompt to your large language model to generate a response, which is the generated part. All right. Any questions so far around RAG or retrieval augmented generation? Is it clear? Okay, I mean, I'll be showing some code as well, so don't worry if it's just a bit confused right now. But there are, of course, like some scenarios that RAG is, this naive RAG, let's say, is not enough. For example, if there are complex user queries that needs multiple retrievals or deeper reasoning, such as like if a user query is something like compare product A and product B using customer feedback. So this time we might want our system to go and get information around product A and go and get information around product B, and then combine this information to generate an answer. For that purpose, our naive RAG solution might not be enough. And sometimes the initial retrieval doesn't provide enough context, so we might need to go alternative resources. We might be using web for that. For example, if you are using the OpenAI or ChatGPT, you see those chat applications now have web search as their feature. Or we need some dynamic and iterative search strategies such as query rewriting or other retrieval strategies like hybrid retrieval or Hive, or there are so many of them right now. And there might be, of course, like several reasons why you might want to go further than RAG. And usually this approach of going beyond standard or naive RAG is agents. And this brings me to my next slide. So, but what is an AI agent? There are different definitions probably, but I think this definition explains it quite well. An AI agent is an LLM-based system that autonomously pursues a goal by interacting with its environment using tools. So you see three underlined phrases there. It needs to be LLM-based system, so we need the brain of the agent that can act autonomously, and it should be interacting using tools. So if you look at the schema here, so there's like a human making sending a query to an LLM. LLM makes an action, and this action is through usually tool calling. Then it makes some changes in the environment or in the information in the context that agent has. Then LLM checks that information and sees if it needs to do another tool call, or maybe now it's reached the goal, so it stops. So basically, it's just LLM and tools in a minimal setting running in a loop. You can call an agent. Make sense? Okay, nice. And I want to also quickly show you the difference between agents and workflows, because I think right now we tend to call everything an agent. That's not true. So probably with this one, you'll be able to understand the exact difference. So it's just you see in there's like a query coming, a response going out in the agent box. Let's say there's an LLM and there are some tools, but there might be something extra on top of that, right? There might be memory or human in the loop. Like you can make it quite sophisticated. But the thing is, it's an autonomous system, and it's suitable if you have a complex multi-system problems requiring diverse actions. If you're familiar, for example, deep research agents, if you need a deep search, then an agent architecture might be suitable for you. Or if your tasks involve multiple tools and sources. So basically, if you have a goal, a clear goal, but you don't know the exact path going to that goal, then an agent architecture might be a good fit for your use case. But it doesn't mean that pipelines or workflows are outdated and not good enough. That's definitely not this true. Because sometimes, so like pipelines and workflows are defined flows. So each step is determined. Maybe there are loops again in your pipeline. Maybe there are like branches or like information coming from two branches and merging together. But in the end, you know the path. For example, if this is a RAG pipeline, if this is a question answering pipeline, or maybe you just simply want to ingest your data or process your data to a system, then a pipeline or a workflow might be a good fit for you. So imagine like, if you can decompose this task, this use case into steps, then go with the pipeline. You don't need an agent for that, although the agent name is quite popular right now. Or maybe like it would be nice if you can use an agent, but you value stability, robustness, and efficiency over the autonomy that agent brings. That might be also a valid reason why you might want to go for a workflow. And this brings me to the vision language model explanation, because I have been saying that like large language models, LLMs, and let's see how the vision language models are different from LLMs. So although like large language models, LLMs are names for really large language models, we are now using them for text-to-text models. So there's like a text input coming in and text output coming out. So basically, language models, text-to-text language generative models are large language models in the field right now. But when we talk about vision language models, we talk about they get text and image as input and they output a text. So the only difference is that vision language models are still big, but this time they can get images. And for that reason, they are quite suitable for visual QA. So if you want to like answer a question on an image data that you have, if you want to go into the details of vision language models, there's a great article on Hugging Face, and in that article we can see how to choose the right vision language model for your use case, the technical details, or how to fine tune one if you want to. So is this difference clear? What's an LLM and what's a vision language model? All right, now the technical part. Let's talk about Haystack and agents in Haystack. So Haystack is an open source AI orchestration framework by Deepset. It's open source. It's a full repository on GitHub. It's a Python package, but at the same time, it's the backbone of our enterprise platform. That's why like it's quite valuable for us. And the whole aim is Haystack provides the tools that Python developers need to build real world agentic AI systems with visibility, control, and efficiency. So if you want to build an agent, if you want to build a RAG application, and document ingestion pipeline. So basically anything around AI you can build with Haystack. And this in Haystack, there are two main building blocks: components and pipelines. And components are the smaller units, so they only have one responsibility, like creating embeddings, generating text, converting documents, classifying documents. Just one responsibility. And by connecting these components, you form pipeline. And pipelines are directed graphs, which means you can have loops in your pipeline, you can have branches, quite flexible architecture. But we also have agents. So agents in Haystack is basically a component, a more sophisticated component, let's say, because actually agent component itself is a pipeline, a very sophisticated pipeline, encapsulated as a component or like as a node to be used in a graph. You can use it on its own. We'll see an example of how to run an agent as like a standalone component, but you can also use it in a pipeline. So you can have something deterministic before your agent. Maybe you let your agent do something non-deterministic, and then you can do something another deterministic thing after your agent. So it gives you this modularity, basically letting you find the right autonomy for your application. And if you look at the architecture here, basically, in order to create an agent in Haystack, you need to provide a language model. And this language model can be from OpenAI, Anthropic, Google. So from big model providers, they can be open models. Maybe you are hosting it through Olama, VLLM. So there are different approaches there. And you need to also provide a system prompt. So how you want your agent to behave. And that's it. So basically, then when you pass a user request, it can generate an answer for you. But if you remember the definition of an agent, it needs to also have an access to set of tools. And in Haystack, you can have different types of tools. For example, you can have Python functions. Maybe you want to do some sort of calculation, a very sophisticated calculation in Python, and has this function as a tool to your agent. You can do that. You can connect to external APIs. There are so many APIs out there. Maybe you want to send a post request or maybe read something through an API. You can turn those APIs into tools. You can use other Haystack components as tools for your agent, or you can connect to MCP servers out there, which are also quite popular recently. So these were the agents, and just a little more information about Haystack. So Haystack has almost 24,000 stars on GitHub now, and there are more than 200 built-in components. Remember, the components were the smaller unit. They only had one responsibility, and there are more than 200 different functionality already defined for you. But of course, if there's like a custom logic that you want to implement, or maybe like a very special tool that you use for your organization, you can create your custom component and put it in your pipeline. There are more than 80 integrations, meaning that there are more than 80 tools like vector databases, model providers, monitoring tools, evaluation frameworks that you can already put into your pipeline and use with Haystack. And if you want to learn different use cases around how to build an application with Haystack, there are more than 85 tutorials and recipes, basically example ready for you. All right, now I think we can slowly go to the workshop part of this. Any questions so far on Haystack? Yeah?
What are the advantages? Can you hear me?
Yeah, I can hear you.
Okay. What are the advantages over, for instance, LangGraph or LangChain? When are we using Haystack here?
Good question. There are several advantages, let's say. For example, I think it's correct. Like you cannot directly compare LangChain or LangGraph to Haystack. I think Haystack is the combination of both. And yeah, so I think in the end, what we are trying to do is to solve the same problem, but through different architectures. I would say Haystack is much more modular and easier to customize. So you can just use those 200 components, connect them to each other, and build your application. So you don't need something. If you need something custom, you can of course do that. But if you need something right now, you can already do that. And I think Haystack is much more production ready, meaning that it's much more stable. It has been around longer than LangChain, actually. And we do regular releases, and we also define the path for you to take your application to production. There's a documentation page that I can share if you also need more information. I don't know. Yeah. Any other questions? Yeah.
I just have a quick question. So, what's the difference between this pipeline? At the end of the day, we fit the pipeline. Am I right? It's like a scikit-learn. We have like we chain different components. Am I right? So, is it any specific difference between this type of pipeline with this agentic, I don't know, style, with those wrappers we have like in scikit-learn, for example? Are there some different advantages right now we are using within this pipeline?
So right now, like by the end of this workshop, we'll have a pipeline. So like the pipeline idea, I think across all frameworks is the same. It's a defined flow. So it's probably gonna be the same. I don't know exactly the pipeline architecture in scikit-learn, but we're gonna have an agent component in the pipeline. So the pipeline itself is a defined flow, but there is some non-deterministic behavior happening in the middle of the pipeline. Yeah. All right, maybe let's go to the workshop part so that we have a better understanding of the agents in the pipeline architecture. So with this agent, we will be able to process images and text together. This agent will have access to two tools. One of them is going to be a database connection, so basically a retrieval pipeline, and the other one is going to be an API connection. This agent will have a memory, so it's going to be a conversational agent, and there will be human in the loop. So this agent will ask us when it will be doing something sensitive. For orchestration, we will be using Haystack as our VLM provider. We're going to use OpenAI, but you can also change that part of the notebook if you want to use Gemini models, Anthropic models, Amazon Bedrock, etc. And we are going to run it on Google Colab. And you don't need the GPU for this, so it should be good to go. Okay, if we are all ready, maybe we can go to that notebook together. I will be also sharing it here. All right, so, but before start working on that agent, I want to show you first this multimodal pipeline example. So through this example, we'll learn how to build an pipeline together in Haystack, and it's going to be multimodal, but it will behave a bit unexpectedly. So we might be also discussing about that. All right, first I will be running this install cell. So installing the packages that I need Haystack AI package for that, sentence transformers to run the clip model, and I have two other packages to process PDF data. So here what I do is just I retrieve three like one of them is an image, so 3 files. One of them is an apple image, the other one is a capybara image, and as the third one I have attention is all you need PDF article. So here I start creating my pipeline.
you see all these components imported from Haystack, and first I create a document store. So this is gonna be my database connection you can think of. There are different options here. If you are using Elasticsearch, OpenSearch, I don't know, Quadrant VV8, you can use them. But the good thing is if you are just trying something easy like a demo or MVP, you can use an in-memory document store, which stores your files in memory, so it's not production ready, so it's not also scalable, but still it should be good to go for this for today's workshop. Then I'm initializing my file type router component. This basically detects the type of the file that I'm passing. You'll understand why I need this component. Then I need a document joiner. I'll also talk about it later. Then I have a converter component that will get an image file and convert it into a document. And document is a special data class in Haystack. So basically, there are different data classes that you can use to pass information down the pipeline, and document is one of them. So I need this component to convert image files into that document class. Then I have PyPDF to document component to convert PDF files into documents. I have a document splitter, so this is basically a simple component that splits my PDF or my data by pages, and so I want my chunks to have 1 pages each, but I can change the configuration here. I can split by words, split by sentences, or I can change this component, this document splitter component, with an embedding splitter to split my data based on semantics. Then I initialize 2 more components. One of them is sentence transformers document embedder. You see the name is quite verbose here. So it goes like sentence transformers document embedder, but this means that this component is an embedder component for document data class, and it uses sentence transformers models. So that's what it says. But this is for text data or for documents. There is also another version of that component called sentence transformers document image embedder that I can use to create embeddings for my image files. Then in the end, I have my document writer component to put this information to my database. So let me just initialize all of these components now, and then we can go to deconstruct the pipeline cell. So is this clear so far, the components? And yeah, all right. Now what I do is like I'm creating my first pipeline in Haystack, right? So I initialize my pipeline object, then I add all of these components one by one to my pipeline. The order doesn't matter. The only thing that matters is like I'm passing the right instance and I'm just giving it a descriptive name. That's it. Then after adding them to my pipeline, I connect these components. So basically, at this stage, they are in the pipeline, but they are like nodes floating around. So now I need to define the logic, and I need to say like how I want these components to be connected. There will be like input edges, output edges connecting to each other. And this is what I do with this connect step. So I say like the file type router has 2 outputs. One of them is for PDFs and one of them is for images. If this is a PDF file, I want this file to go to PDF converter component. But if this is an image file, then it needs to go to the image converter. So what I'm doing is basically I'm processing PDFs and images separately, but in this one pipeline. So you can go into the depths of that connection. Let me create that, but you can also call this show method of pipeline and see the image of it. So what is happening here is like I have this file tab router, so I'm gonna pass the 2 images, the apple and the capybara image. Also the attention is all you need PDF file to my pipeline, file type router is going to detect, oh, this is a PDF, this is an image, and forward them to the relevant branches. If it's a PDF, it's going to be converted into this document type you see here, and then it's going to be passed to the document splitter to split it into smaller chunks. Basically, each page is a chunk, and then it will be sent to this sentence transformers document embedder component to create embeddings, dense embeddings for each of them. And then what's happening for the other branch is like there are images. What I do, I'm not doing any splitting whatsoever here. I'm just converting them into documents and then creating an embeddings for the images as well. Then I join them with document joiner because at this stage they are all in Haystack document object type. I join them together and then I pass it to my document writer so that they are stored in my database. Yes, wait, could you wait for the mic? Sorry. Yeah.
So just that I understand correctly, so the document joiner, in a sense, creates an array or a list of all the documents. That's what it does?
So it basically gets the documents processed in two branches and merges them together in a sense that they can now, like from this point on, I can process them together. Yeah. You know, like you would think that this is like such a simple thing to do. Like, why do I need another component for that? Like, it just gets two lists and puts them together, and the order is also doesn't really matter. But the thing is, this gives me the opportunity to first of all serialize all of these components, all the pipeline later on when I want to take it into production. And at the same time, now it's quite modular, but I can inspect what's happening at each component. So if there is a problem in this list, I can see the outputs of these embedders and check like were the embeddings okay or were the problem with the document joiner. So that's the whole idea behind doing, like, basically building so many smaller components and connecting them together. And now I have my pipeline ready. All I need to do is to run it with the data that I have. And these are already, like, after running this cell, now these files are stored in the Files tab of my Google Colab notebook. So I can just run this pipeline with those files. But what I need to pass is that, so I want these files to be passed to the file type router component, which was the first component of the pipeline, and into its sources input edge. So here I can define, like, maybe like based on the component, the name of the input edge changes, but here I need to find the components and the right input edge. So when I run this one, it just, what it does, like, it checks if it's a PDF, sends it to the splitter embedder. If it's an image, it just sends it to the image embedder. And to create embeddings for images and text, I use this clip model that is basically open source and available on Hugging Face. So it is also downloaded to my notebook now. All right. Now it's ready. I think, yeah, the run is done. So if I just go to my document store instance and call all the documents with this filter documents method, I see that there are like 17 index documents. Basically, like 2 of them are images and the 15 of them are the splitted version of my PDF file. Makes sense, right? Basically what I did, I processed the files and put them into my database. Now I am gonna do a retrieval. So I basically come up with a query and I'll try to retrieve relevant information from my database. That's a retrieval. But it's a multimodal retrieval because my data, this data that I store in my database is with images and text. So there's not one modality there. So in order to do retrieval, first, like there's like a user query, right? Then I need to create an embedding for that user query as well, but using the same embedding model, because I want these embeddings to be in the same vector space. Then I calculate the similarity. Then I get the most similar, I don't know, 5 chunks, let's say, or 10 chunks. That this is a parameter that I can define. So this time I initialize my sentence transform as text embedder, because this time the input is text. I need to embed that, but again using sentence transformers models. And now I'm passing the same model to this component again. And to retrieve information, to create this connection with my database, I initialize this in-memory embedding retriever that accepts the document store instance, but it does embedding retrieval. So it might be also doing BM25 retrieval if this was the way that I want to go for. Then what I do, I run my text embedder component with a query, an image of an apple. So I want the apple image to show up with after running this query. Then I pass that embedding, the created embedding to my retrieval component so that it retrieves the relevant information. And when I run this cell, then with this for loop, I go over all files or relevant files that retrieved from my database. But what I see here is that although I know that there was like an apple image and a capybara image, and what I'm looking for is an image of an apple, I retrieve the attention is all you need file as the first 5 relevant chunks. And if I go into the all retrieved chunks, because I think by default with the retriever, the top K value here, top K, if I say, so I can change this number, I can say 5, 10, but I think by default it's 10. So I should be able to get 10 documents here. Let me remove that and run this cell again. So if I look at the all retrieved files, document 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's always the attention is all you need file, but not my Apple image. Do you see the problem here? Yeah. Wait. Sorry.
Thank you. Do you have a tool in Haystack to visualize where the image embeddings or the text embeddings are?
Yes. So basically, if you if we go and see the text embedding here, yes, we see the, visualize in a sense that like in the vector space, you mean?
Yeah, I mean like a projection, like OMAP.
We don't have that. Sorry.
Thanks.
Yeah, but do you have an idea why this is the case? Would you say that it's expected or unexpected?
Well,
like this thing happening?
Well, clip is very different. It was trained on images that are 2 to 4 times 2 to 4 and chunks of text that are like describing them. It's most likely much different domain as what you're using here. It's probably not a good embedding model.
Yeah, I think so too. I think the reason behind this problem is like, because if I'm putting images and text into the same database, I expect like if there's a query coming, but if the image is more relevant to that query, I would like that image to show up first than my text. But probably, although this is like a multimodal embedding model, this model, the clip model, is not that good, because like it might be a reason like the way it was trained, or the modality is actually really important here. Yes, maybe it works really well if you do image to image retrieval or text to text retrieval, but if you want to do cross modality retrieval, then it's not the best embedding model. I think that's what I think. I haven't tried any embedding models because there are like, if you wanna try them, wait, I'm gonna remove that. There are different embedding models you can already try with Haystack, Cohere, I don't know, Gina, or through Amazon. So yeah, you can take a look at these models and see if they perform any better in this multimodal retrieval. Yeah.
Are they separate? Do you have image embeddings being compared to text embeddings in a notebook? I didn't get this part, because if you were to compare the image embeddings and the text embeddings, and it's I don't know how you're extracting the text embeddings. It must actually match, like the ranking of the most similar text,
Cosine similarity.
the cosine similarity,
Yes.
and the ranking. The cosine similarity is not going to be high between images and text in clip. The ranking is going to be high when the description and the text matches. The two embeddings are in ranking, like in relative ranking. The image that matches its text description is going to have the highest similarity among all comparisons, but it's not going to be a high cosine similarity. It might be 0.2, it might be 0.3. So
Okay.
if you keep the embeddings of text and image separate, and you compare all image embeddings with all text embeddings, and this is done correctly, then the image embedding that corresponds to the best matching text embedding should appear at the top of the ranking.
So you say that like putting them into the same database and comparing them through one embedding is not the right approach. First, I
No.
need to compare through modalities.
Exactly. You need to have a set of image embeddings being compared with a set of text embeddings. If you mix them all together, if you mix all the text and all the images, the similarity, the nearest neighbors are not going to make sense.
Okay. And okay, that's something that I learned today. But do you think that these like newer models might be better in that sense?
I have not tried them.
Okay. All right.
I have
Yeah.
a notebook on clip that I can share with you.
Okay. Yeah, I'm gonna also try them once with this approach and see if they perform any better. All right. So this was just like a quick introduction to Haystack pipelines and how you work with data. Yeah.
Yeah. So two quick questions.
Yes.
One, can you because what I understand, I just want to fully understand it. So in one hand, we are like one input is like the text. You mentioned here is this Apple
Yes.
text. Okay, and
No, the Apple image, by the way.
Apple image.
Yes.
Yeah, and also this text. Is it an image of the Apple?
No, there is no text. It's just the image.
That's not the. So can you comment on two things? I noticed that this index and index is like 17. So I checked the PDF. This is 15 page.
Yes.
So like including these two JPEG photo, it means 17.
Yes.
Am I right? So and another thing is I checked the length of this text underscore embedding. This is like a 768. What is this? Can you comment on that? Why the length is 768?
Which length? Sorry.
This basically snippet you mentioned to check text underscore embeddings. So I was checking the length. So is it like how, scoring? Can you just check the length of this?
It's the length of the embedding.
Exactly. What is this? Can you comment on that quickly?
Okay, so basically when you use an embedding model, it means that you get a text or image in the sense, because it's a multimodal embedding model, let's say. It creates a vector representation of that image or of that text, and having this length of 768 means that the length of this vector representation is like 768. So this vector has 768 dimensions. And this is by the way, the text embedding is the embedding of this text. So an image of an Apple text, when I use this clip model, has the vector representation with the dimension of 768. But this is because of the model that we are using. If you're using a different embedding model, you might have a different dimension. Or there are also, like, for other newer models, you can also define the dimension of the vector that you want to have. Does that answer your question? All right. Let's wait for the mic there. Okay. Okay. Then. Okay. First you, then you. Sorry.
So my doubt is also similar to the one the other person asked here. So for example, we are searching for an image of an apple through the images, which is being embedded.
Yes.
What if the document also contains a text very similar to it? So we put all the embeddings together. Then in that case, even if the text has something relevant to it, it's going to show the same PDF instead of the image. Even if the embedding model is better, like the image embedding model, which we use, if we use a better one also, it's still going to show a lot of PDFs, right?
That's true. So, like, even this sense, although we have the image of an apple, it brings me the text saying that it is more relevant chunk. So in that case, it's definitely gonna bring me that PDF or that textual information higher than the image. Yes.
Then my question is, in the pipeline, should we optimize in such a way that there is a differentiation between the embedding vectors of a text and an embedding vector of an image? So there should be some kind of an identification so that the retriever model doesn't get confused.
Yes. Basically, you can make a more sophisticated. First of all, you can change your indexing idea and say that, like, I use this embedding model to generate embeddings for my images. I use another one for my text files. So basically, all you would have to do is to replace these embedding models with something else, embedded components with something else. You can still use the same pipeline. And then when you are doing retrieval, you can do maybe metadata filtering here, basically by no, not here. Here, when you're running a retrieval, you can also pass I think that the key was the filter, and you can say that, like, bring me the documents. No, I think the thing here was like type that is, like, I don't know.
Yeah.
Something like that. So like you can let the user decide, like, what type of information that they want to get, and based on that filter, you can filter out your database and then do semantic similarity on that smaller space.
Okay.
Yes. All right. There, and then you. Yes.
Yeah, thank you so much for this workshop so far. One thing that I didn't really get is, why does this PDF show up so many times? Sorry for that. Probably.
Yeah, good question. It's because this was actually one PDF, but then by using the document splitter component, we split it through one page, like we split it from pages, and then created chunks for each page. That's why, like, all of them are different parts of the page of the PDF. But yeah, since the path is the same, that's the reason. Yeah.
Yeah, thanks for the workshop so far. I'm not really sure, because I think the clip model is translating images and texts to the same embedding space, and that makes them comparable, like for a RAG application like that. Well, it's not RAG right now.
Yeah, it's just retrieval, yes.
Just retrieval. So I was thinking, why is it so bad? Like, I mean, a picture of an apple and the sentence, "This is an apple," it should be more closer than a research paper.
Yes.
Right? Like, is there a logical error in the code, or like, what is your assumption there?
I think, like, that was like the conversation that we had over there. I think we can definitely discuss this further, like, after at the networking part, because I would agree with you, but at the same time, I think we need to check the model card and see, was it really trained like that, or was the purpose different? So like this is definitely not an error in the code, but the way we use the model, I would say.
Which model?
This clip model.
Okay, like what do you mean with use it?
It's because we are trying to put the images and texts, although they are in different modalities, into the same vector space, but the representation of these files or modalities are not that straightforward. So that's why like when you are comparing text, it gets closer, like the similar chunks are always the text because the modularity is the same. But if we had passed an image, probably we would have gotten the image.
Isn't exactly that the purpose of the clip model, to make it comparable?
I'm not sure. We need to check the model card. I think it should have been the case, but when I look at this, I don't see that happening. So this was just like a conversation, like a discussion that we could have, and I'm happy that we are having that. And I also see hands there. Is it about the clip model?
No, just right on your browser.
Oh, sorry. Yeah, OpenAI clip. I'm gonna say yes.
Yes, and go to this one, connecting text and images. Scroll down.
How much further?
Scroll down, scroll down, scroll down. This part in the approach, yes. Open this overview A. You see the clip model has two vector encoders. You have one encoder for text and one encoder for images. So one produces a vector that has size 768, another one produces a vector that has size 768, but you see that they come from two different bases. These are two different models. Well, actually, when you use a text encoder from Clip, you use like a BERT type model, and the other one is a vision transformer, the image encoder. So what you're doing during training is that you take the dot product of these two embeddings and you try to maximize what matches the description. And that means you're going to have a high cosine similarity between matching image text descriptions. And you can also use it to compare image against image embedding and text against text embedding. It works well that way, but it doesn't work if you put everything together and you try to find what is the most similar thing. That's why you're getting like all these results of PDFs. You need to partition the two embedding space in two different spaces. You compare images with images, or text with images, or text with text.
Yes. Does that make sense? I mean, to be honest, if I see an embedding model that is multimodal, then I would say I wouldn't expect this behavior, but yes, that's the case. Yeah.
I can give maybe some background why this happens.
Yes.
So there's a quite interesting phenomenon. It's called typographic attacks. So if you type it now, clip typographic attack.
Like this?
Yeah, typographic attack clip.
Should I write like clip or
clip,
something?
Yeah, just clip.
No, that's it? Okay.
No, clip. Did you write clip? No. The clip
yeah.
model, yeah. Then...
Don't make me go to archive.
Maybe add OpenAI. Yeah, now click on multimodal neurons.
This one?
Yes. Then you scroll down. More. More. More, we are almost, yeah, that it is. Okay.
This one?
So, yeah, exactly. So what's happening is, on the left you have the image of an apple.
Yes.
And the model is embedding it as an apple. However, if you put in the text, then it's embedding it as the
text.
The text, yeah. And if you put in now this PDF file of attention is all you need, The model is basically reading the text inside this PDF file and embedding it as something like a text. I don't know, maybe there's some sort of text.
Yes and
abstract
no,
text
though.
embedding.
Like I have to interrupt you here because I use this PDF to document converter. So I extract the text from PDF already, and I use this model to create embedding. So if I go to my pipeline here, you see, like here in this part, I convert that PDF by using PyPDF to a text already. So it's not just I'm passing this PDF page. So I'm passing the text in that PDF.
Then it's just too much text for the model, right? It's just trained on one
maybe,
sentence.
Yes.
Okay. All right, thanks.
Yeah. Okay. No more questions around clip. Sorry, we still have an agent to build. All right. That was it around this multimodal retrieval pipeline. And as I said, if you want to check if other models behave the same, you can try other embedding models from these providers. But now the agent part. Now we need to really go fast. Okay, let's go fast. So here we're gonna build a multimodal agent. We're gonna use a vision language model in this agent as the brain. It's gonna have access to 2 calls. It will have a memory, and it will have human in the loop feature. And here I wanted to build something useful, but so basically the idea of this agent is gonna be, at Deepset we have a social budget, basically a defined budget for each employee for us to use our social activities together with other Deepset employees, like lunches, I don't know, taking a class together, going out for a beer, etc. And when we do those activities, we need to just upload the receipt to our finance tool, and then we reimburse the money. That's how it works. And what we're gonna build here is that this agent will have access to the Deepset's social budget policy. It will understand the receipt that I'm uploading to the receipt that I'm giving to that agent. And then it will tell me if I can reimburse this receipt as a part of my social budget or not. And if I can do that, it uploads it to the finance tool that we have at Deepset. So that's the story behind it. So now we need to install other dependencies, but this time we also need these markdown packages to process markdown files. So here we provide the OpenAI API key, or if you want to use Google, you can also use the Google models, but I would tell you to do some extra stuff. If you are using a different model provider, please go to those pages, or if you can also go to Haystack website and the documentation there. And here under pipeline components and generators, you'll see other providers. For some providers, you might need to install some extra packages, and the API key name changes, so pay attention to those if you want to run it smoothly. All right, let's go back here. So I'm using OpenAI. So for that, I'm gonna pass my OpenAI API key here. All right. Now I start building my multimodal agent. So if you just remember how the agents were created, how the agents were defined in Haystack, they just need a brain and a system prompt and set of tools. And here is my component. I imported from Haystack components.agents, and I have my OpenAI chat generator component that I will be using as my brain. So I initialize this OpenAI chat generator with the model that I want to use. But since we are creating a multimodal agent, I need to use a model with vision capabilities. So I cannot use old models or models without vision capabilities for this demo. Just something to keep in mind. And then I pass that generator to my agent, just as a simple example. This is not how you're supposed to use the agent, and that's why it gives me a warning saying that no tools provided to the agent. That's why the agent will behave like a chat generator. So without any tools, basically agents is no different than this OpenAI chat generator component. So basically any LLM that can run standalone. And there is also like a warning for that in Haystack. But now I just want to see if I can process images with this agent. That's why I didn't pass it any tools. And to process images in Haystack, what I do is I need this time the image content data class. And this data class comes with different methods. One of them is from file path. You can also use like other versions or other methods. But since I have this, or I don't have this here, so I need to go back to this notebook and get it from here. Sorry about that. Let me paste it here because I don't have the Apple image in this notebook. Now I have it. And now what I want is like, what I'm doing is like I'm converting an Apple image into an image content object in Haystack. Then I pass this object with the prompt, with a text, and create this list. And I'm asking like, what fruit is this and what is it, its color? And then I pass this content parts as a user message to my agent components. So basically I say agent.run, I pass a list of messages, and my first message is a user message that I'm passing this image and text. So let's run this cell. Is it clear why I'm passing a user message here? It's basically because this is how you would communicate with an LLM provider API. You like when you're passing when you're sending a request, you're sending a JSON that has a role of either user. It usually has the user role, but if this message is coming from the API, then it has the assistant role. Maybe it's like it has a tool call, etc., etc. That's the reason why. And now it just what does, like it took this text, the image, send it to the OpenAI API and got the result back. And the result is, if I print the text, I see it's an apple. Its color is a mix of red and yellow. So if you also visualize the apple image, you see that is basically true. So my vision language model works. Now I know that. And if I run results, the messages field of result, I can see the whole messages. And like I can see here the text that I'm sending. I can see the base 64 image, base 64 string of this apple image I put. Then in the response, I can see the number of tokens here and which model were used. So if I need more information around my request and response, I can have it here in this messages list. All right. Let's now start adding the tools to our agent. And our first tool is going to be the retrieval tool, basically our database connection. And for that, first, I need to create a database with some information so I can do some sort of retrieval. And I create a simpler indexing pipeline or ingestion pipeline. I again initialize my document store. This time I'm using Markdown to document converter because I'm gonna be passing a Markdown file to my I'm going to pass a Markdown file to my pipeline. Then I have a document cleaner component, which basically removes all the white spaces, like irrelevant spaces in my file. Then I again have a document splitter, but this time I split by word, to be precise, 150 words. And there is always a 50 words overlap between my chunks. So like a sliding window type of thing. Every 50 word is common between, like is shared with the previous and the next chunk. And again, I'm using a sentence transformers model, but not the clip model this time, another one. And I have my document writer component. And what I do, I add these components to my pipeline and I connect them as I want them. You see like some of these components are commented out. It's because you can add them, or you can also like If you want to have different, if you want this pipeline to process different file types, you can add those to your pipeline. Yes. Now as my pipeline is getting initialized, now I'm gonna go ahead and add more files. So let's go to my, so if you go to the workshop repository, in the files folder you'll see receipt and social budget policy MD files. You can upload both of them to your notebook. We're gonna need them. So first what I do is that there's this markdown file, social budget policy. I pass this policy to my pipeline to put it into my database. And this markdown has information around the policy at Deepset, like it has some requirements, some rules, etc., etc. It's a mock document, let's say. And here, as the result, I see that this markdown file were split into 4 chunks, and each chunk were for each chunk I created embeddings and I put them into my database. Then I create the retrieval pipeline. So this time I, like, instead of just running the embedder and the retrieval separately, I put them in a pipeline. I connect them, and then I'm gonna run this pipeline. The important thing is, again, I'm using the same embedding model that I use to create embeddings for my documents. That's the whole trick. But we know how it goes so far. And right now, when I run this pipeline with a query very as simple as social budget, it should bring me some relevant information around social budget. But since I only have one type of information, I mean, it will bring me, and any information that it brings is going to be irrelevant. But that's not the case. The point is it can retrieve information. Then, so I have this retrieval, but I need to convert it into a form so that I can pass it to my agent. And for that, we have a pipeline tool object in Haystack. So basically, if you create a pipeline or if you have a component in Haystack, you can easily convert it into a tool by using those converter classes. And with pipeline tool object, what I do is that as the pipeline, I pass this retrieval pipeline that I just created. Then I do some sort of input mapping. So like when you think, if you have worked with tool calling before, each tool has some parameters and some output parameters, some input parameters and output parameters. And what I do is that the input parameters of my pipeline, I convert it into something simpler because I would ask my agent to do this mapping, and then the output parameters of my pipeline, again, I pass it here. I do some sort of mapping, and I pass a name. I will need this name when my agent does a tool call. Then I create a description. I say search information for company policies at Deepset. So I explain here why I want my agent to use this tool. And then I do something extra here is like, so when I run this pipeline and when I retrieve documents, in the document objects, I see some irrelevant information like ID, this very long one, or I also have the source ID. So if I just get this all information and put it into my agent, it's just too much context that my agent doesn't need at all. So with this outputs to string function, I can process the output of my pipeline and just get the relevant information before I pass this data to my agent. And here, basically what I do, I process these documents through this doc.string function. And in this function, I just get the file path of each document and their content. And I just like create a very long string with this information. Does it make sense so far? Any questions? Bilge, what are you doing? Like right now, it's getting so complicated. Does anyone think that? Okay, question.
Yeah, I
Yes.
mean, I guess my question is actually before when we used the policy, you just briefly showed the markdown file. Maybe you just wanted to glance over it. It wasn't so important, but I was just trying to understand. I mean, I just briefly looked through the markdown file, which is the company policy. I understand that it's supposed to enforce certain rules, right?
Sorry, it's what?
It's supposed to enforce certain rules.
Yes.
Right. I guess, like, how do we know it's actually properly going to enforce those rules that we just put in a markdown file? I know it's supposed to follow. I mean, it's just a very optimistic assumption, I guess, that we're taking here. Can we maybe look a little bit at the markdown file? And I don't know. That was just would be nice if you could maybe go a little bit through.
Yes.
Yes.
Okay, let's do that. So basically why we have this policy is that imagine you have so many different policies in your organization. Your agent will be able to get the relevant policy from your database and then combine that information with the information that we provide, and will be able to tell us if it can follow this, or like what we are doing is compliant with the policy that we have or not. And here are some of the rules, for the social budget policy. Is that okay? Like, it explains why that's the case for social budget. So it's basically to encourage social interaction, promote inclusivity. Since like Deepset is a remote company, it's a team building incentive, let's say. And there are some rules for this social budget thing. Is that each Deepset employee is fixed with monthly budget. So there's this monthly budget that people need to cannot exceed. And the minimum requirement is that you need to have one more Deepset employee with you when you're doing this social interaction. Otherwise, like, it's not a social budget. And so it's not something individual. You have 50 euros per month, and it goes under your team budget. And here are some of the options. You can have like team lunches, coffee, drinks, some sport activities, cultural activities, team celebrations, etc.
Yeah, I think that makes sense to me. But this is the only time we actually mention these guidelines and the rules. Like, we just provide the policy, and at that point we assume that the model understands them and enforces them. I guess we have the human in the loop later where we can actually say yes or no. But okay, that was just my question, if that's the only time where we actually enforce the rules.
Yes and no. Right now we just create this connection. So we don't actually teach our model this policy. We just tell it where it can find it if it needs that. So right now we haven't done anything, and we're just gonna see if it can understand when it needs that, and if it can like produce the right query to find the relevant information. All right. So what I do if I go back to here is that I process the output of my retrieval pipeline, so that when I'm passing this information to my agent, I just remove the irrelevant information. Let's initialize that. And when I call the parameters of retrieval tool, I see that in the description. So when you're working with tool calling, if you're introducing some tools to your LLMs and want to do tool calling, you need to create this JSON schema explaining each parameter of your tool. Like, here are the parameters, here are the types of these parameters, and the definitions of these parameters, and why the LLM should use this tool, etc. So there are like a long JSON schema that you need to provide. But if you follow this approach, this pipeline tool class, it is handled for you. So you don't need to worry about like to create the exact JSON schema that your LLM provider would need. It's handled by Haystack under the hood. All right, let's now create the agent with this tool. So again, I initialize it with my OpenAI chat generator. I give it this time a longer prompt saying that you're a helpful Deepset agent. the Deepset employees are using you. Here is the list of tools that you have access to. This time we only have the retrieval tool, and like consider all the information, ask for more information if you have enough details, like kind of like very basic stuff. We are just like saying that you're a helpful agent, you have access to these tools, act like this. Let me initialize that. And now when I'm initializing this new agent component, I pass this system prompt, I pass my chat generator, the LLM or the brain, I pass the list of tools, then I also pass this streaming callback function. It's like a built-in function that we have in Haystack, helping us stream the tool calling and everything that's happening in the agent in real time. So now when I run this agent asking like, what is the social budget limit? I'm hoping that it will go ahead and call this tool that I just defined. So here under this tool call, I see that it asked for, like, it queried this retrieval tool with this query, social budget limit. So it did some query rewriting to find the relevant information, and then the tool, basically my retrieval pipeline, returned this information, basically a part of my markdown file, and then my assistant, so the final response of the LLM saying that the social budget limit is 50 euros per employee per month. It's just an agent making a tool call, basically retrieving relevant information from my database. Now I can introduce images and see if it can understand the image files and do this retrieval at the same time. So I uploaded this receipt, and this receipt is basically a lunch receipt that I had just last week. You see like the total amount here, you see the place, you see the time. So it has all the relevant information, most of the relevant information that my agent needs, let's say, to say if it's okay for me to use my social budget with that. And basically this is what I'm gonna do next. I convert this image file into image content as I did before, and I pass this image with this text saying like, can I reimburse this expense as my social budget? And what I expect this time is that my agent first needs to understand, like, it should be able to read the receipt and get relevant information from my database through this retrieval pipeline and combine this and tell me if it's okay or not for me to use it. So let's do that. Okay, now I see, I'll put it something. So, okay, it went to the retrieval tool again. It asked for social budget reimbursement policy, found relevant information. I see under tool result here, this is the relevant information. Now it's in the context of the agent, and here the response. So it says like the receipt is for a meal costing 10.40 euros, which fits within the Deepset's social budget meal specific guidelines, etc., etc. Okay, it makes kind of a mistake here, but that's fine because it understands that it's the reimbursable amount is like 10 euros per person, but it also says that it fits within the social budget. I think it's kind of it gives me more information saying that, however, to be eligible for reimbursement under the social budget, it says the meal must involve at least one other Deepset employee. So it kind of assumes that you can send it, because in the social budget markdown you see that the amount of one receipt can be like 10 euros tops. But now it tells me that, okay, it passes 10 euros, that's fine, but it should include another Deepset employee, and there are other requirements, like it should take place between 12:30 and 1:30, and ensure that the Deepsetter names are there, the description of the activity is there, etc., etc. All right, question, yes.
Thanks. Could you please explain what is happening in the background? So you're sending a request to the OpenAI server?
Yes.
which is then telling our local client to call the tool. Then it's running on the client and then sending back the results to the OpenAI server. Or
Yes. So let me open a OpenAI page myself this time. All right. So basically how tool calling works is that when you're communicating with these large language models, you can tell them like, here are the list of tools that you have, and here is the query. And what it returns to you is just, it tells me like, you need to call this tool with these parameters first to find to resolve this query for me. So I just passed this like tool definitions and message, so the user query, to my model, and my model returns like, call this tool with this parameter. So I need to execute this function myself if I'm communicating with these APIs directly, but I don't do it because Haystack does it under the hood. Since I provided the tool already, my agent calls the tool because it knows which tool to call. It knows which parameters to use. So it does the tool calling. It gets a response from the tool and passes that response back to the LLM. And the LLM can return with another tool call. LLM can return with 2 parallel tool calls, or LLM can tell that this is the final response because now it has access to the user query and the tool results, so it can generate the final response for me. And what happened in our example is that it saw the receipt and it's got the query and it thought, okay, first I need to call the retrieval tool to find relevant information. Then it passed me the parameters and the retrieval tool name. I made the tool call, passed that again to my LLM, and LLM combined all of that information and returned me the final response. Yeah? All right. Any other questions around this? Yes.
I would guess at some point the policy of approving or not an expense would be done in an automated fashion. Couldn't that be manipulated with an injection attack, either through text or through image? And does it make sense to approve something like this? This is a low-stake thing, but it could be higher-stake policy enforcement. Don't we need a person to make sure that there's no funny business at some point? Otherwise, a lot of these things can be exploited.
Yes, but so far we are only doing a read action. So we are not like sending information. I mean, we are sending information just to the OpenAI API. So we are not writing anything so far. And reading, I would say, is rather secure. Yes, but there will be a part where we're gonna write, and for that we need some security. Yes, and I'll try to show something around that. All right, I'm moving because we are running low on time, so I want to go through the whole notebook with you. So this time, as the next step to this application, we can add a memory. And memory meaning that, so right now when you send a query to your LLM, okay, yeah, it does the tool calling, etc. for you, but when it returned the response, now it doesn't have any more information around your query. So when you send another one, so when you want to ask a follow-up question or something, your LLM doesn't have the context because it only has the user query. But now I will put a memory. Basically, I will store the whole conversation somewhere with an ID so that if I want to ask something follow-up, or if I want to like stop the conversation here and come back, I don't know, like 2 days later, I can do that. And for that, it's basically like we store documents for the retrieval pipeline, but this time what I store is the messages that I exchanged with my LLM previously. And this is an experimental feature in Haystack. That's why you need this Haystack experimental path this time. But this experimental package comes with the Haystack main package, so you don't need to install another one. Let me run the cell and explain what we are doing here. So I initialize another store, but this time a chat message store, again in the memory, so I keep everything in memory. I have a retriever component that is connected to the message store, so it's like an embedding retriever, but it just retrieves information, not through embedding. And I have chat message writer, which is similar to document writer, so it writes the messages to my message store, and that's it. But so like the agent component, when you think it's just a node, but there are like user messages coming in and agent response coming out, and I want to save them both. That's why what I do is like I create a pipeline, another pipeline, and I will call this one a conversational agent. I will add my agent component that I initialized, that I created like here above. Oh, that's a very long context. That I created, oh my God. Yeah, it's here. So I get this agent instance and I put it into this pipeline here. Then I put my message retriever here and message writer to my pipeline, and I connect them. And basically how this connection looks is this. So when there's a user query, first it gets to this retriever. Retriever gets the previous conversation. Just like one thing to underline here is that I'm not doing semantic search or like cosine similarity here. It's just like a basic get action through the chat history ID that I'm passing to this retriever. So it gets the previous conversation, it gets the user query, the new user query, adds that to the list, and sends this list of messages to my agent this time. So with this approach, I have all the previous conversation that I had with that agent. Then agent generates a new response, and I get this message and write it to my messages store so that it is stored in my memory for the next iteration. Does that make sense? Yeah. So this time I'm gonna do the same thing. So I'm converting this received into an image content. I have my text, I have my query with the receipt image, but I need to now keep track of this chat history ID. I'm gonna say like chat1, and I'm gonna run this pipeline. And in order to run this pipeline, I'm passing this chat message to my message retriever this time because it's gonna combine it with the previous conversation. And I need to pass the chat history ID so that I know which conversation that I'm keeping track. All right, let's run this agent again. It's not gonna do something different. It's just the same operation that we have done. So it does the tool calling with the query. It reads the received and it generates an answer from me. So it gives me some instructions around like how it can be reimbursable, like, and it basically can read the receipt. It just works. Now, what I can do on top is that I can ask follow-up questions like, what is the total amount for social budget per month? And when I run the cell, let's go. So this time when I'm running the agent or this pipeline, I'm not passing the image again. It's just the query. But since I'm storing the previous conversation now, my agent already has access to the image that I passed and the previous conversation and even the tool result. That's why instead of making another tool call and retrieving relevant information, because in order to answer this question, it would need some more context. But since that tool result is also stored in the conversation, it just takes a look at the previous conversation and it gives me the answer. It doesn't make any other tool call. Makes sense? Kind of expected because like the list of messages are already there, but like something that can be a bit problematic here is that every time now I add another message to this list, all of these messages are gonna fill up my context for this LLM. First, it's gonna fill in the token limit for me, and it's gonna be even more costly after every message because this tool results, tool calls, all the previous conversations, all this text is in the context all the time. Yeah. And if you go to this message store through this retrieve messages, you can see the full message history. So you see like there was like a user message and then an assistant response, so LLM response, and there was like the tool results store, which is the markdown that I stored. Then there was another user request or follow-up question and the assistant message coming. All right, before we add the last tool, do we have questions so far? Yes.
Yeah.
Wait for the mic,
second,
sorry. Microphone.
So there's currently no mechanism to delete old messages in this context history, conversation history.
Do I want like some messages to go or all messages to be gone?
You could do something like a ring buffer that you delete the last messages if a certain token length is exceeded.
There is no mechanism to remove by token, but you can remove. So when you are, if I go back here, so basically you are passing a last k parameter to your retriever. So you can say like only return me the last 5 messages or
okay.
2 messages or something. Yeah.
Okay, thank you.
But yeah, there's nothing you can do, like at least like on the Haystack level, you cannot set the token. And I think that we can also discuss if that makes sense or not. Like what if you split it in the middle of the content or something? Yeah.
Yeah, that's one valid way to do it.
Yeah. But you can say right now, I think by default it's like it gets all the messages. So unless you set the last k value for your retriever, then it's gonna bring the whole message list.
Yeah, this will eventually crush the memory and also the context window. So this wouldn't make sense.
Yes,
it's necessary to provide a k parameter, I think.
Yes, but one thing you can do is like you can put another language model here between your agent and your writer component, and you can tell it to summarize the messages. And instead of passing like the exact messages directly to your message writer, so basically storing the list of messages all the time, you can just store the summarization of it as an approach if you're worried about the context.
So one could also add this as a tool or as a component in this.
As a component, yes. Basically, all you will have to do is put an OpenAI chat generator or any other chat generator component and tell it to like summarize this list of messages, and it will summarize like the output of that component will be the summarization of your messages, and you would be storing them. So you can already do that because since this is a pipeline, all I had to do is like add that component to that pipeline, make the relevant connections, and that's it. So I can already do that.
I think they do the same approach in Copilot if you use the agent tool. They also summarize the messages each, like, I don't know, 5 turns.
Might be, because, yeah, you can easily fill up the limit.
Yeah.
Yeah, especially if you're storing the tool results, we do. Yes.
Okay, thank you.
Yeah. Any other questions? Yes.
So basically, we are storing the chat messages alone, like the chat sent in the chat is being stored in memory, or the original MD file is also being stored as a context?
The MD file is not stored, but the information we retrieved from the MD file is stored because it's a part of the tool result. So when we retrieve information through that tool, it is stored, but the markdown file itself, it is stored again in the memory, but in a different instance, let's say, not as a part of messages.
So is it possible for like text injection? So for example, I send in a message saying that Deepset has changed their policy to increase per employee 150 euros per month, and that gets being used into the OpenAI, and OpenAI responds with a higher bill saying that this is possible. So injection is possible, right?
Injection is possible because you can, so if you see this list of messages is under our control, so we can easily retrieve the messages, this list of messages, and put an extra message into that list and store that as the new list of messages in our store. And basically, and if there's no one checking, then this list of messages are sent to the LLM, and the LLM can say that, oh, the policy was that, but then it was updated, the user told me so I will listen to what the user says, and I say, like, I ignore the content and follow what user said.
Wouldn't it be an interesting idea for you to add the original source of truth as well as a component, so that every time it also references to the original source of truth and prioritizes that over some kind of an injection, because it acts like a guardrail then to your tool call.
Then how can you detect which one is the original one?
Give more weightage to the original document over an enforced order rather than a question.
Yeah, so like on the memory level, like this memory store level, I think something like that can be done. And this is a good idea, and that's also one of the reasons why this feature isn't experimental right now. So it's open for feedback and open for testing. Yeah, thank you. Yes.
I have more questions. I want to ask just in case we are asking a lot of the questions, and for each time before this agent answers the next question, it will just read the list of the message that we have for the formal history. Is that right?
Yes.
And so the answer that you will get is will be totally limited about from the ability of the LLM and how it will read the history of the list of messages. Is that right?
Yes.
In case we have a lot of a long list of the message, and the LLM have the problem to deal with it, and maybe there's some confusing message in the list of the message, and the LLM cannot deal with it very clearly, so it will just give you a very confusing answer. Is that right?
Yeah, that might be a possibility. Yes. So like even when you're communicating with ChatGPT, like if you're using the same conversation screen, let's say, and if you're like jumping from topic to topic, yes, like the agent kind of gets confused. The LLM kind of gets confused. Is that what you're asking? Yes. So that's a possibility, yes. And you might be even like, there might be some conflicting information in the same list of messages. So this is also something problematic for the LLM. So which information is the true information? It will find it very hard to find.
So the agent is totally limited by the LLM that you use, right?
Yes, exactly. Yes.
Okay, thanks.
Because that's the brain that we are using for the agent.
Since the mic is here. I was wondering, I mean, you can build arbitrarily complex graphs here, right? And maybe something breaks and you want to debug this in a way.
Yeah.
Does Haystack come with any built-in monitoring or debugging tools or something like this? Because I imagine that this can be quite complex, right?
Yes. So thank you for asking that question. It gave me a great opportunity. So
I was not paid for this.
So basically, like you can easily connect to a monitoring tool like LangFuse, Arise, or there are also like alternatives out there, and it gives you the breakdown of all of the tool calls, or that's the reason actually why we build such a modular system, because you see the outputs of each component, and agent itself is actually a component, like a pipeline, a very sophisticated pipeline. So you can also see the outputs of each component in the agent component itself, like it's smaller units as well, but you need to connect it to a monitoring tool to in order to like visualize it better. But if you go to Haystack documentation again, and there should be like logging and tracing pages. I think this was the tracing one. Oh yeah, this one. So if you enable this tracer in the even in the notebook level, you'll see like all the details of like the you see like there was this component and the input type, the name of the component, the input coming to the component, the output of the component. You see all of them even like without connecting it to a monitoring tool, but it's not very easy to visualize. So that's why like, but it has the, so you can use this if you have something custom and you can connect it already to your system, or you can use like these. I'll take you this integrations page and monitoring tools, and you can use one of these, and we already have connectors to these tools. If you, and with just like initializing one extra component, you will be passing that logs to your tool. Yeah. All right. I continue now. Let's go. All right, last tool. So this tool is gonna be our connection to the finance tool that we have at Deepset, but unfortunately that tool doesn't have an API, so I had to come up with my mock Python function. So I define a Python function. I say that its name is send reimbursement, and I define some parameters, but if I use this annotated type, I can also give the description of this parameter. So this will help my agent to understand how to create the tool calling for me when it wants to use this tool. And then I also define a docstring here. This is gonna be the description of the tool. Again, it will help my agent to decide when to use this tool that I'm defining. And I'm doing a very simple thing here, and it checks the amount coming. And if the amount is larger than 10, it tells that you cannot reimburse this amount. But if not, then it says like we received your request. So imagine like this is you are doing maybe here some sort of like a request, HTTP request here, and you parse the response and you pass the information back to your agent, and that's a mock of that. And right now I reinitialize my agent. What I do differently is that I put the send reimbursement tool to my prompt, and I briefly explain why it should use that. And I also add that tool to the list of tools here with my agent. Now I create the pipeline with the memory again. And now first, like the other thing that I need to change here is this chat history ID, so that we don't use the previous conversation with this agent. We start something from scratch. But yeah, I can skip that one, and I can just run this one. So again, I pass my receipt, and I say that I had lunch with Alex and Jack. Here is the receipt. Can I reimburse this expense as my social budget? Like the query we did before. The only difference this time, it has access to one extra tool, but it doesn't. Wait, we did something wrong here. How did you know? Okay, because we didn't change the chat history ID. Let's run it again. Yeah, okay. It made the tool call for me. It got the tool result, and in the response, it's still generating, so I cannot scroll. Yes, it tells me, yes, you can reimburse this expense as part of your social budget, etc., etc. So it has all the information. But now I say that, okay, now I want it to use the send reimbursement tool that I just provided it. So I tell it to like go ahead and submit this expense. So I wanted to call to this send reimbursement tool with the relevant parameters. So let's see if it can do that. All right, yeah. It's called the send reimbursement tool with the amount 10.4, with the currency, euro, and the description, although it got the date wrong. But the tool result told me that this amount cannot be reimbursed, and that's why my assistant told me that there was an issue with submitting the reimbursement. Please try again later or contact the finance team for assistance. Okay, like there were some unexpected things. So like why October 2023? It's probably because of the LLM's cutoff time. So it doesn't have access to the current time. So it just puts that information to the prompt. But this is a kind of like a sensitive thing because now instead of just reading information, I'm also writing. So I'm sending a request to a tool. That's why it might be a good time for me to incorporate human in the loop, meaning that so if there's something sensitive and I define what sensitive is, this agent will get a human approval before it continues with that action. So in this sense, I'm gonna create a human in the loop strategy for this send reimbursement tool so that every time it uses that tool, it asks me. And again, this feature is experimental, although it's going to be in the main, so in the core repository with the upcoming release end of this month. I'm importing some policies from Haystack Experimental, and there are 3 policies in Haystack. Always ask policy. So if I use that policy, every time the agent uses that tool, it asks my approval every time. Ask once policy. So only once it tries to use that tool, it asks for my permission. The never ask policy is just basically the default one. So you don't need to use that one if you don't need any other policies. So now when I'm defining the agent and the tools, after putting all of the information I provided before, I define this confirmation strategies and I say that when you're using the send reimbursement tool, always ask me. Also always get my approval. But when you're using this retrieval tool, ask me once. So like, let me give you the access to that tool once. And depending on that answer, you can use that tool or not. So after defining those strategies, I initialize my agent again and I put it in my pipeline again. And now I run the same scenario with the agent. So now I again expected to use this retrieval tool, but I expected to call, like, ask me first because I defined this ask one policy. And for the UI, we also have this rich console UI that you can use. So that makes this interaction a bit more human friendly, and it also imported from the Haystack library. So here now, instead of just calling the tool and getting the information, it asks me and it tells me like, I'm gonna call this tool and with this query, do you confirm, do you reject, or do you want to modify the parameters? But I don't want to modify anything. I'll just say yes. So it continues with this action. So it does the retrieval and tells me if I can use it for my social budget or not. But this is not something interesting. I want to use this other tool and I wanted to submit it to my finance tool. So that's why I add this query, say like, I had lunch with Alex and Jack, go ahead and submit this reimbursement. So now it calls this send reimbursement tool, but since I told it to ask me all the time it uses that tool, it asks me, oh, okay, this time it got the date correct. Nice. So LLMs, you never know. So now I know the arguments, but I know that if I say like 10.4, it's gonna reject. So I want to modify the arguments. So for the amount, I'm gonna say like make it 10. For the currency, euro is fine. So let's continue with that. And the description, yes, I want the same description. I don't need anything to fix here. So let's go and fix that. See, this time, since I had the correct I fit the requirements, it passed, it's submitted to my tool, and my assistant says like it's submitted successfully. All right. There's also one small like cell that I add here. So since we are doing this conversational agent, so we can ask follow-up questions, if you just want to have a chat with this agent, you can just run this cell and it creates this while loop so that you don't need to like run cells over and over again. You can just like type your input there. So it just makes it easier for you. Like it gives a more human-friendly interaction UI. But apart from that, this was all I wanted to show you today, actually, in terms of code. So I can come back to my presentation and tell everybody thank you. So if this was interesting for you, you can join the Discord community, Haystack Discord community, under that QR code. And if you are interested in building AI agents with Haystack, there's a data camp course. And there I show you how you can combine structural information like an information stored in an SQL database with unstructured information and build an agent that can combine them both. It's also a fun course. And again, you can find me on Twitter and on LinkedIn. And I think this is also what you guys would like me to show everybody here. So if you have any feedback, you can scan this QR code.
Yes.
And
so with this, please give a big thank you to Bilge.